All right. Hello, everyone. My name is Dixon, and I am a developer advocate here at ZenML, and I'll be your host for the closing ceremony of month of MLOps tonight. And on behalf of the ZenML team, firstly, I'd like to welcome everyone who is joining from all across the world right here. And today also, we're happy to be joined by our distinguished judges. So first, we have Charles Frye. Charles, welcome. Charles is a core instructor of the full stack deep learning course. So happy to have you here. And we also have Goku Mohandas. Goku Mohandas, who is the founder of the Made with ML, an incredible resource for applied ML. So welcome. And unfortunately, today, two of our judges, Chip Huyen and Anthony Goldbloom, could not make it to join our live event, but we're happy that everyone contributed to the judging. To those who are new, we've been running month of MLOps competition for the past 1 month. And the goal of this competition is to pick an ML problem of your choice and try to put it into a production-ready stack within just 4 weeks. And for each week in the competition, we had a theme, just so that we can set the pace and the rhythm of the competition. And in week 1, we had our theme was to encourage team formation and coming up with a problem that you can solve and maybe come up with a prototype solution, right? And for the second week, we were experimenting with models, with data, and iterating over it many times. And week 3, we had participants try to deploy the models using the various tools that we have, and the last week, monitoring the model. All right, so before we start our ceremony here, I'd like to just briefly mention here are what we can expect to happen in the next few minutes. And up next will be a presentation by 5 teams. And each team, they're expected to present their solution. And the presentation should not go over 5 minutes. So please make sure and be aware of the timing. And we also have a session, What's Up with ZenML, just to give time for the judges to finalize the decision. And after that, we can have our judges' feedback, result announcement, and the closing remark right next. All right, then, without further ado, we will now proceed to our first session today, and that is to have our team present their solution. And the presentation order is arranged alphabetically, and each team is given a maximum of 5 minutes to present your solution to everyone and the judges here. And the first team to present today will be, let's take a look, Marina. Marina, are you there?
Yep, I'm here. Hi.
Over to you.
Okay, awesome. Can I share my screen?
Sure, I'll stop mine.
Okay. Just a moment. Oh, that's the wrong one. One more second, sorry. There we go. Okay, so hi everybody. My name is Marina. I live in the Bay Area in California. I'm a machine learning scientist at Twitch. And the problem I'm trying to solve today is sometimes it's hard to know if you're a cat or if you're not a cat. So this app helps if you upload a selfie. I can try to help answer that question for you. So the pipeline is shown here. It's relatively simple. The training pipeline starts with a data validation step that's done with deep checks. I'm using the non-tabular or the computer vision checks that they have. And then there's a validation report that is saved out. The data comes from a couple of different sources. So I have some images of cats, dogs, selfies, random images. The data prep itself is pretty simple. The images are reshaped and normalized, and that's about it for now. And then the model is trained. This project is using a 2D CNN implemented with TensorFlow and Keras. Currently, I'm just training locally. In the future, I would like to use SageMaker or something for that. And then the model hyperparameters and training metrics are saved using MLflow autologging as experiment tracking artifacts. I also did some hyperparameter tuning with the Keras tuner. And then the trained model predicts on a holdout validation set and logs those metrics to MLflow as well. In the deployment pipeline, the training pipeline is extended and implements a continuous deployment workflow. So it does the same steps as before, inputs the data, trains the model, and then redeploys the prediction server if the model performance meets some evaluation criteria, so some minimum recall and precision. There's a deployment trigger step that does this evaluation, and then the model is deployed using MLflow. For inference, I have this simple Streamlit app. So you can upload a file or a photo, a little selfie. So here, we have a cat. So it's going to upload. It'll show you, this is you. And then we're going to predict. I'm pretty sure you are a cat. Awesome. Got that one right. So then here I have an opportunity for user feedback. So in the future, I could potentially make some changes to the model, add some monitoring, drift detection, that kind of thing. And similarly, here we have our previous governor of California. So we're going to see, is he a cat? He's not a cat. Yay, we got that one right too. Yep. So that's pretty much it. There are a ton of things that I would like to do. This is a pretty simple kind of prototype at the moment, but I had a lot of fun putting this together. So I really appreciate the team for setting up this event. And that's all for me.
All right. Thank you. Thank you, Marina, for your presentation. You actually have some time left. All right. So let's now move on to the next team then. And the next presenter will be Shiwalika.
Hello.
Take the mic.
Hi. Am I audible?
Yes. Let me know if you're presenting something. I'll stop my sharing.
Yeah, sure. I'll start presenting. Is my screen visible?
Not yet.
Okay.
Now it is. Yes.
Okay. Is it visible now?
Yep.
Yeah. Okay. So hi everyone. I'm Shivalika. I just wanted to say thanks to the ZenML team and the judges for giving me a chance to showcase my project here. So as you can see, my project is called Check Easy Banking with Transformers. And before I show you the actual project, I just want to give a high-level overview of what check processing looks like within the Indian banking system. So hypothetically, let's assume Hamza gave me a check, and then I go to my bank and deposit that check. And my bank will basically scan that check and send it to a central body called the clearinghouse. And then the clearinghouse will basically request Hamza's bank for a bunch of his details, maybe his signature and his account related details. And then it would basically do a bunch of few things to verify, right? It would basically check whether the date on the check is valid or not, if the amount in figures is matching with the amount in words, if his signature is matching or not. So every check basically that is submitted to the bank has to go through this elaborate process. And now imagine if a bank has thousands of branches serving millions of customers, uh, even if as low as 30 to 50 checks are deposited at a single branch, you would still end up with hundreds of thousands of checks that need to be processed within a single day across, the multiple branches of the bank. So clearly, you cannot scale this problem without machine learning. And the solution, the model that I have chosen to implement this solution is Donut, which is a new deep learning model for visual document understanding kind of tasks. And I've fine-tuned it on the task of information extraction. And there were a bunch of reasons why I chose Donut. Firstly, I needed something that was accuracy, that had high accuracy, because we're dealing with financial data and money is at stake. Next is I needed something that was cost effective, especially during inference, because we would need to process hundreds of thousands of checks. Next is I needed something that could be easily extended to a multilingual setting, because in India, people submit checks in lots of different languages. So um, I
I think he'll be back soon, I hope. Maybe just a temporary hiccup.
Let's hope.
Yeah, we'll get it out of the YouTube video, Shvalika, don't worry.
Is she still in the call? Oh, she is.
It looks like the laptop or computer maybe ran out of battery or something, because that's when you take a bit of time to rejoin. So that's a good sign, because you might rejoin now. Let's give it a few seconds, otherwise we can maybe circle back to Shvalika when she's back.
So let's move forward.
Maybe let's give her 20 seconds. I think that would be fair. She was in the middle.
The
We
thing
have some
I found
music.
exciting with Shvalika's project was this donut model. I didn't know that there was an open source, like pretty high quality document understanding model. Big transformer that just outputs JSON to describe your documents.
Nice.
Was that on Hugging Face that she got it?
Yeah.
It's fantastic. All right, Dixon, then I suppose we can keep going, and when she comes back, she can complete the presentation. I think that's the best way forward.
All right, then. So let's just move forward with our next team while waiting for Shvalika to be back. All right, and our next team, oh yes, an interesting one, doppelgangers. I'd like to invite team rep to present.
Hey, can you hear me?
Yep.
Okay, I'll share my screen. Okay, hey, I'm John from Fuzzy Labs, and we looked at Dobble on the edge. So it's not just me that worked on this. There was a whole group of us that are all pictured there. So what have we done? So naturally, we wanted to conquer the competitive world of Dobble, and what we did was trained a model to recognize the common symbol between two cards, and we used ZenML to help us do that. But you might be wondering, what on earth is Dobble? So it's a game of speed and observation where the aim is to identify the common symbol between two cards. If you're the quickest person to find it and then say it, you win that card. So essentially, it's a more sophisticated version of Snap. To build on what we've done, so like I say, we trained a model to recognize the common symbol between two cards. But to make this even more interesting, our model runs on the edge, so specifically in the NVIDIA Jetson Nano, mostly because it's a concealable device. So how did we do it? So this is kind of a high-level diagram of our solution. So we have a camera that can see two cards. It isolates those cards, recognizes the symbols on those cards, finds the common symbol, and then reports that back to the person that is trying to cheat. And ZenML made this quite simple and easy, because we wrapped all of our data processing and model training into a couple of pipelines. So I've obviously left out a lot of detail, but we produced quite a large amount of content. So we have a series of 3 blog posts that cover the data science behind the solution. So we used some object detector model, the pipelines and the challenges that we had around putting that on the edge, and then obviously the deployment MLOps on the edge. So I encourage you to go to that link there to see what the details were. And we have this sort of short video that shows the model working. So you can see that there's 2 cards, and the matching symbol is the double symbol on that on those 2 cards. And then the next set is a ghost. So that's our solution. That's our implementation. I'd like to say, obviously, thanks to ZenML for hosting this competition. It's been really valuable for us as a team, and we got quite a lot out of it. So that's us.
All right, thank you. All right, thank you for the presentation, Doppelgangers. And now let's move on to our next team to present, and that will be the Transformees. Over to you.
Yep, I'll be sharing my screen now. One moment. Okay. Oh. Okay. Sorry, give me 1 second. Are you guys able to see my screen now? Huh.
Yep.
Sorry, I think permissions. Oh.
Oops. You're muted, Andrew.
Okay, I'm gonna ask my teammate to present because, or have him show the demo first until I can get this working. Yeah, Alex, can you pull up the demo on your side, and I'll get the rest fixed.
Just a second. Yeah, sorry, we have some problems on the background, but I'll try to get this.
Okay.
Right.
Can you guys see it
Very
now?
nice. Yeah.
Okay, finally. All right, sorry about that. So I'm Andrew. My teammate's Alex. Today we're presenting our application here, Admire. It's basically a visual question answering system. So you can see my face in the webcam here. I'm just going to use an example for right now. So I took an image of my dog and I asked it, am I a person? Inference usually takes about 10 to 15 seconds. So in the meantime, I'm just going to talk about, why I chose this project. So I did this project for the full stack deep learning's final project. But in that time, I was only able to write the deployment code. So I wasn't able to write any of the data management or the model development code. It was pretty bare bones. So the main goal of this project was working with Alex here to write all of that. And yeah, as you can see here, it returns correctly. No. We can try another example. Just a picture of myself. And I ask it, what color is my shirt? So you can see here the background is totally different. It's completely different, and it answers white correctly. So like I say, it has a fairly decent understanding of what's going on. So Alex here will now talk about the pipeline itself.
All right. So the basic premise of this architecture is that we have an image. In our context, is the webcam image, and then we want to ask a question. So in this example, we have how many benches are there in this picture. In the pipeline, there are like 4 main pieces. The main thing is on the right side, the GPT-3, which makes the final inference. But there are also 3 other models running alongside. The first one is the few-shot images that gives the few-shot examples for the GPT-3 model with the help of the database of images and the question we give it to it. Then we have an image captioning model, which is a vision transformer mixed with GPT-2 that creates image captions, which will be the actual context for the image we are trying to get the answer to. And then alongside there is an object detection model that gives tags such as benches, slides, and swings in this particular image. So the main pipeline is that we ask the question, then we get the few-shot examples to give the context, how to answer to these kind of questions. Then we give the actual image context, which is the kids' playground with the slide and swings. Then we have the objects from that image where we have slide, swing, 2 benches, and a tree. And then we get the correct answer, which is 2 at the end.
Awesome. And so now I'll talk about the how we incorporated ZenML. So we incorporated it as part of our data management, and more specifically, the data validation. So we used its integration with Great Expectations, and we run a data check offline on the entire training and validation set. And we log all our results to S3. We log it to a bucket. And as you can see here, all the files that Great Expectation saves is saved here. So we have that for offline monitoring and just for ourselves when in development. And so the main repo is structured as different folders that each describe a part of the project lifecycle. So for example, API serverless describes the backend handler code for using AWS Lambda. There's App Radio that manages the front end code. And this really allows for a seamless interaction with the code itself, both in development and in production. So in development, it's really easy to test certain parts of it. So for example, if you want to start running an experiment or start training, it's just a file within the training folder. If we want to start the app locally, it's also just another command away. We also have another testing folder named task, which is just a bunch of shell scripts. So we can run it with relative ease. And this allows for a really easy production setup too. All we really do is just set up a couple of terminals, and we run App Radio. So we just run the Gradio app itself. We port it with local tunnel so that we have a permanent link. And we just run this shell script, which simply just constantly checks to see if there are any push commits to the repo. And if so, we check the performance. And if it's improved, we simply just push a new Docker image up to AWS Lambda. That's our presentation. The website's here at admira.loca.lt. And the GitHub repo is also attached here. Thanks.
Awesome. Thank you for the presentation, Alex and Andrew. All right, then we'll move on to our next team. And our next team will be Team 2.
All right, sounds good. I'll share. Cool. All right, hope you guys can see my screen. So hi everyone, my name's Simon from 2. 2 is a B2B BNPL company, and we're representing the data science team of a couple colleagues on the call today, Joseph and James in particular. Shout out to them. And as part of the month of MLOps competition, we decided to try get our feet wet with the ZenML framework and build something end to end. And we're particularly interested in how ZenML can help us in the work that we do every day. And so as part of that, we decided we would build an end-to-end pipeline for both training and deployment on a subject area that's close to our heart as a data science team in fintech, which is financial fraud detection for financial transactions. And so we ended up developing the Streamlit app, which is sort of inverted in terms of how I want to present this, because I explain how to interact with the model first, but we'll just go ahead and scroll down, explain how and why we made it. So I've given a bit of background on what we were trying to do here, but effectively we decided we wanted to use ZenML to give us an indication of how it would work in our day-to-day workflow. Picked up a off-the-shelf data set from Kaggle, so this is the synthetic data from a financial payment system data set, and then went ahead and developed a model. First sort of went through an ideation phase, more Jupyter Notebook based, and then sort of as we got clearer as to what features we wanted to engineer, started building a proper model, building a proper pipeline, training pipeline to help us in our experimentation and training and fine tuning. As part of that, we encoded all of the feature transformations within that pipeline and sort of already noticed how much simpler it was to iterate on that once we had ZenML's caching ability and being able to run on with remote orchestrators. And then the second part of our project was then to actually extend this to a continuous deployment pipeline. So we went ahead and extended our training pipeline and included some drift detection and a deployment trigger, and then at the end a model deployment step to Selden. So here's just an overview of the stack that we used. We were mostly working on GCP, used Evidently for data validation, MLflow for experiment tracking, and then ended up deploying on Selden. Also, using Kubernetes for orchestration, which was a fun experiment after trying a bit of Vertex AI. And just to give you a bit of a visual overview of what it looked like at the end. So we had our training pipeline, which was fairly simple. I hope that's sort of visible for everybody. And then the deployment pipeline was a little bit more involved. So what we actually did was we assumed that the baseline data of the data set we had from Kaggle, we sort of took a piece that we assumed was the data we had at the T0, right? And then split out another piece that we would only get later in the continuous deployment pipeline, as we would do in a more realistic scenario. And then essentially in the continuous deployment pipeline, we would detect data drift between the original baseline and the new data. And then depending on if there was data drift and if the model that we trained met some expectations with regard to model performance, would we go ahead and deploy that model to Selden on our Kubernetes cluster. So that's sort of an overview of our training and deployment pipelines. And we explained this at length sort of in this Streamlit app, but then I just want to take you guys through this front end that we built. So what we did is we built a bit of front end that would allow you to input sort of arbitrary transactions or feature values for the transactions to the model, and particularly also let you recreate historical transactions of the original data set, because we observe often in this space, it can be interesting to know how and why the model responded to particular past instances. And so generally we try and make that easy through this app. So first we have a possibility of recreating a historical transaction. So maybe I have, a transaction at 10,000, and then the feature values for the model are sort of put as the default values on these sliders, Obviously, these are our actual features for the model. In reality, if an end user was using this, it would probably be something a little bit more high level. And then we can go ahead and run off a prediction. So in this case, for this historical transaction, 10,000, 0.01% probability of being fraudulent. We could also randomize if we close the replication here. Another one, but if we then sort of create a counterfactual transaction, for example, the transaction amount, which should almost definitely lead to a fraudulent transaction. So this was something that we had a lot of fun doing and sort of gave us a lot of inspiration for our day-to-day work. And yeah, hope that gave you a bit of an insight as to what we were doing. And thanks again to the ZenML team and all my team members for first of all putting on this competition and working with me to get it done.
Wow, thank you, Simon and Team 2 for the presentation. And now, Shivalika, are you ready to take the stage again?
Yeah, Dixon, I can
All right.
go ahead.
Go ahead, whenever you're ready.
Sure, just give me a second. I'm really sorry about earlier.
No worries.
Okay. Yeah, is my screen visible now?
Not yet.
Yep, it's here.
Yes, now.
Okay. Yeah. So earlier I explained about the business problem and the modeling solution that I chose to address this problem. Now going forward, of course, having just the model that can extract these details is not enough. You need a whole pipeline that can help you basically build and sustain this model. So that's where ZenML comes into picture, and I was able to create a bunch of different pipelines to basically build the end-to-end solution for this use case. Before we even get to the training of the model, I needed something to basically take in raw data, being able to annotate it, process it further, and to create the final data set that can be used to train the model. Then I needed a training and deployment pipeline, which I can use to do the actual training of the model, evaluate it, and then finally deploy it. Next, and finally, I needed a pipeline for doing inference where I can load the incoming data, send the request to the model, and get the final prediction results. As all of you know, with ZenML, it's very easy to set up the infrastructure that you need to run all your pipelines. And I was able to create those stacks and with a bunch of different components that I required. In my case, the data processing stack is slightly different from the training and inference stack. And all of that is very easy to set up using ZenML. I've used Label Studio as annotator and MLflow for experiment tracking and model deployment. And here is the final demo of the project is available on Hugging Face Spaces. And I'll just quickly show, this is a simple app. I'll just quickly load in a new check and just click on this call donut button. And once it finishes running, you will be able to see that it extracts all these fields, like the name of the payee, the amount in words, the amount in figures, the date of the check, the name of the bank, and a bunch of these details. So as you can see, it has extracted all these details. And then it's done a few additional post-processing checks, like comparing the basically the amount in words with the amount in figures, and checking if the check is expired or still valid. This check is dated 6th May, and right now it's November, so it's been more than 3 months. So this check is stale. So yeah, this is just a simple app of and explores shows up how this how to go about implementing one aspect of this solution. Of course, there's like a bunch of other things that can be done to enhance this project. So yeah, that's it. Thank you for your time.
Wow, thank you, Shivalika, for the presentation. All right. Now that all the teams have presented their solutions briefly, and right now we'll give the judges some time and space outside of this meeting to kind of finalize their decision, and then maybe after 3 to 5 minutes, they'll join back in. And in the meantime, while we're waiting for the judges' final decision, we'll maybe have Hamza to talk a little bit about what's going on with ZenML recently. Hamza, over to you.
Thank you so much, Dixon. What a fantastic bunch of presentations. Thank you everyone so much for contributing to the month of MLOps. It was our first one, and we hope to do many more. But it's so amazing to see people from the industry all the way to complete like newbies or beginners into the space of MLOps, using ZenML and all the other fantastic tools in the stack to create such creative and visually appealing as well solutions. So everyone had a front-end demo. This is just great to see. I'm going to be using the time that the judges are judging as just a small presentation or more of a chat to the people in the room and the people listening on YouTube about ZenML and where we are today and where we're headed. And I know that we talk about these things a lot, and we have a lot of presentations, and every week we meet as well, but sometimes things get lost, so I thought I would take a moment to just step back and see where we made it. So I haven't made a lot of slides, but except these, and these are the slides I presented a month ago, about a week before the competition started, actually, when we made this big 0.20.0 release with ZenML. This was our biggest release to date. It really was one of the most hard. Yeah, it's one. I speak for the team who's here today as well, that we literally removed tens of thousands of lines of code of ZenML and ripped out the architecture and re-architected it to go from a client-based architecture to more of a server-based architecture. And this architectural change, what that led to, and I'm going to go a bit in detail here, it was the removal of the metadata store as the part of the stack component, which used to be a sort of a bothersome part of ZenML's stack configuration, given that we got a lot of feedback from it, and we put that all behind a simple server now. And we also made stack sharing and configuration very easy with this release. So it's the start of something that will push us also further in the vision of ZenML, which is to bring all the tooling of MLOps together into a coherent, easy-to-use, standardized framework. And this, of course, one of the biggest things that we that got enabled through this change, through this architectural change, was the ZenML dashboard. The ZenML dashboard is the open source companion of the main ZenML repository. It now comes bundled into it. It is a React app, but we do bundle it with the Fast API server now. So whenever you have a ZenML server deployed, you also have the application deployed or the dashboard deployed. And it's a separate open source repository that sits in the ZenML in GitHub as well. And you can see a demo of it here. I'm sure most of you have seen this, but for those of you who haven't had the chance to play with it, it has a pipelines view, a pipelines DAGs view, where you can see all your pipelines, your artifacts that flow through ZenML, and you can see all the configuration. And you can also see where each pipeline runs on which stack. So for example, this pipeline runs on a Kubeflow Gitflow stack and has all these components. You can see that in this view a bit better. And if you want to see, for example, what the configuration of a particular component was, for example, my artifact store here, you can see the configuration lives right here in this track centrally. These changes were very important because we wanted a more visual representation of ZenML, and a lot of things that ZenML did was sort of lost under the hood, especially for people who are new into it. And the dashboard serves as an entry point into it. And finally, the future looks very bright. We have a very constantly updated, but also constantly filling backlog of things that we're working on. Of course, if I go into the public community roadmap, you can see that every one of you also votes for these things. So we know we are listening to the community. We know that hyperparameter tuning in DTC is a big feature. We know conditional branching is a big deal. We are getting to that, trust me. Some of the biggest problems that we have in ZenML today are to do especially with stability. And I think I speak for everyone when we say Mac M1 support is a big deal, right? Python 3.10 and beyond is a big deal. We are working towards that, and we are getting rid of the dependencies that have hampered us into making us a bit faster, especially in the stability part. And within the next month, we should be sometime next month. I don't want to put the team under a lot of stress, but sometimes next month, hopefully, we should have M1 support, and in the next year, we should have hyperparameter tuning and integrations into DVC and conditional branching in the early part of next year, and introducing critical components like model registries and a bunch of more features. You will see an update to the dashboard as well. You will see you could do a lot more with the dashboard when you go into the DAX visualizer view. Perhaps you would be able to see a lot more stuff here, which step ran on which stack component, and just you can easily navigate between all your stack components. I see that the judges are back. I don't know if that was enough time. Alex, are you ready? All right. Well, I'm just going to end by saying thank you to all the participants, and I won't keep you waiting for long as the judges are back. So, Dixon, the floor is yours. Let's see what the judges finally decided.
All right, the moment that we are waiting for, and right now looks like the judges are done, and we'll just jump into the judges' feedback right now, and after that we'll dive into the announcement. And Alex, would you like to take the session?
Yeah, actually, Charles is going first, I think. So go for it, Charles.
All right, then.
Yeah, so just I think before we give the actual prizes out and do all that, just some high level thoughts from me and from Goku. I think, and there's detailed feedback on all the projects. I had a ton of fun looking through all of them and writing, as much feedback as I could on what I thought people did well and where I thought people could improve. But I think the main takeaway for me from this is how far MLOps has come as a discipline. In my view, like the definition of DevOps is it's the tooling that allows developers to own things that are in production. There was a horrible time in the past where developers wrote source code, people installed software from CDs, and there was a giant gap between them. And now the gap between what you do as a developer and what a user sees can be zero, can be epsilon small. And that has happened for classical software 1.0, over the last 2 decades or so, continually improving, so to speak. And to see that happen now for MLOps, to make it possible for an ML engineer or an ML researcher to actually own not just the model and its metrics on holdout validation sets, but it as an actual application that users can interact with. That's so great to see. And it's like, it's something, 5 years ago when I was, in the middle of my PhD working on this stuff, like an impressive demo was if you had it in a Jupyter notebook and not just a terminal. And now an impressive demo is if you can have it running on your webcam at the same time as you're showing it in a Google Meet and like have 5-10 people interacting with it at once. That's the new minimum viable product. So that's just so awesome to see. I think this is like the goal of MLOps as a field, is to make that possible. And so big kudos to all the team members who were able to get that tooling together and make these things. And then also, of course, to the ZenML team who are building this critical layer for composing tools that make these things possible. And just one last point on that. The goal here is to make 2 pizza developer teams and smaller more effective. That's the classical mantra from DevOps. And I'll note that all these teams are like 1 pizza teams. And in addition, to make people who don't have as much expertise in operations able to work more effectively. And so I'd also like to note that the range of people in this competition runs from people who are absolute MLOps experts and are using these tools to accelerate and push themselves all the way to the edge, all the way to Andrew, who I believe was in high school in April, and so and is now able to deploy a GPT-3 powered ML system of composed large models running in the browser, all thanks to this tooling. So just really incredible work from everybody from inside the competition, outside the competition, and as a field. And I'm really excited to see where these projects individually go and where the field goes as a whole, shipping better tooling and better applications.
Wow, thank you so much for such a detailed and extensive feedback there, Charles. All right, then I'll hand it over next to Goku for your feedback.
By the way, let me make connections to you guys. I think it's because there's so many videos on, which is great, but don't turn them off. But I think I would echo a lot of what Charles said, so I'll just kind of a few additional points. From my side, or specifically, or could be everything. Let me take off. Is that better?
Much better.
All right.
Oh, okay, I think you're right. I think it was towards I've been using them all morning. Okay, so I'm just gonna add a few more additional points to what Charles said. But wow, I think the bar for what these projects look like, it's just going up. Not even every year anymore. Every like 6 months or so. Charles runs a fantastic course, and I've seen other companies in the past also have small versions of this, and just the quality of projects just keeps going up, which is amazing. And I think it's a combination of kind of where the industry's headed on the research side, but also people in the tooling landscape just making it so much easier and faster for people to actually build production systems. I had a couple different, I guess, points. One is just creative projects all around. Even the people that were learning this for the first time, maybe you're using a use case that's quote overused or trite, but everybody put a creative spin on what they were doing. So just amazing to see that. Let's see. I think so. I spent a lot of times with small companies, Fortune 500s, and some of the things that these teams have done, I don't even see like Fortune 100 companies sometimes doing, and that's around like data validation. And it's not just validation for the sake of doing it for the competition. I think you guys have actually thought about what should be validated, and then using like some of the things you discovered during the monitoring phase to kind of add to the validation aspect. So just love the domain specific use cases of validation and monitoring that I saw, as opposed to just kind of slapping something on, especially in a month's time. So that was amazing. Let's see, very mature practices around management of data assets and training, even though, building data engineering pipelines is not part of, how traditionally people think of MLOps. A lot of you really took ownership there and built something quite mature, actually. Let's see, I think the last thing that surprised me, and I was talking to Alex and Hamza about this before the call, I've known about ZenML, I've seen ZenML used, I have never seen it used in so many different contexts. And I went through maybe it's the mistake of doing this, but I went through all the projects at once. So I was just like, wow, this is all these different use cases, all these different stacks, and people are able to kind of use this unified layer, and it's just getting started, right? We're not even at 1.0 yet. So just amazing to highlight ZenML, highlight all of the different projects that people are working on. And the best part I'll add is that I saw almost every project here. use libraries that don't have official integrations yet. So you didn't let kind of the current constraints slow you down. So you just used it because you know it's a workflow that had to be there, a job that needed to be done. And that's great feedback for the ZenML team to get working on those integrations so they are officially part of it next time around. So super impressed. I'm sure all the other judges are also sharing that. And yeah, we're excited to share the winners now.
I'll just maybe make some kind of small remarks, I guess, on behalf of the ZenML side of the judging team, I guess, because I know you're all eager to get to the final results. So yeah, definitely I echo Goku and Charles's comments. I mean, for sure, like the entries showed that MLOps is a complicated thing, right? Even if some entries like chose to focus on like one particular area versus another, it was really impressive how everyone like somehow managed to fit all of the various pieces into what they were building. And I think another thing that came out was quite interesting, that demos of MLOps projects are actually quite hard. It's like a dance performance versus talking about like the concrete and the wood on which the dance performance is taking place. It's like, yeah, you see a cool demo of something happening, but actually what you want to talk about and what ZenML is enabling is all the stuff around it. And definitely in the future we'll try and see and think about how we can kind of encourage like more of that kind of superstructure to be visible, or yeah, other ways around that. Yeah, and in general, like we were really pleased with how many beginners participated and submitted entries. We see this as kind of a validation of what we're doing, that we enable people who really haven't been working in MLOps, or maybe hadn't even heard of MLOps before they started the competition. And yeah, it was really gratifying to see all of the work that everyone was putting in. We obviously kind of saw people checking in on the office hours and on Slack and so on. And yeah, in general, we were just, as a team, we were super impressed by all of the submissions that we had. So yeah, I think now the moment you've all been waiting for. So, Dixon.
All right, just gonna share my screen. And Alex, you're making the announcement?
Yep.
Whenever you're ready.
So we will start off with the two most promising entrants. So these are kind of people who are early on in their MLOps journey. So to start with, we have the Are You a Cat team, which is Marina. If you have 15 or 20 seconds of words you want to say?
Yeah, thank you so much. This was fun. I learned a lot.
We enjoyed your project. And the second most promising entry goes to Team Admirer.
Wow.
Thanks, guys. I want to say thank you, especially to Charles, for the full stack deep learning course. It was my first course into the field. And so this has just been a way to help me improve on it. Thanks, guys.
Thank you. And moving on to the next category. So for third prize in the main prize category, we have Team Check Easy, which is Shivilika, if she's still here.
Yeah, hi Alex, thank you so much. I wasn't expecting this, but like, thank you guys. Thank you to the judges as well. It was great like learning and working on ZenML with ZenML. Yeah.
Thank you for submitting. And the second prize, appropriately, is Team 2.
Perfect. Yeah, that's what we're aiming for. No, in all seriousness, didn't expect this. I think we all had a great time working on this project. Thanks again to you guys for putting it on. And yeah, great. Had a great time.
And we have a drum roll for the first prize.
And the first prize, I'm sure it's no surprise to hear, Fuzzy Labs, the team double gangers. Congratulations, guys.
Congratulations.
Brilliant. Thanks, guys. We like I said on the thing, we learned a lot doing this, and we're quite keen to see how far we can push this on the edge devices. So yeah, thanks a lot.
All right. Congratulations again to all the winners. I'm just so impressed by all the solutions that were submitted. Well, I really hope that this will also inspire every one of us in the audience today to start just building your solutions, start playing around. I'm sure there'll be many, many more solutions the next time we organize this. And we are now approaching the end of our session here. But before we end this session, I'd like to also invite Adam to just say a few words as the closing remark.
Yes, that's amazing. The first one left already because I wanted to make a group picture because it was such a big success. It would be amazing if you can turn on your camera if you would like, and we make one big screenshot and then also talk about it, because we will make history, because that's the very first time the very first time today, but there will many other follow. So that would be super cool. Super many. So people are leaving because it's close to the hour. Are you ready for a screenshot? Amazing. Also, the others, feel free to make other screenshots. That's perfect. Cool. Yes, so as closing remarks from my side, guys, it was really a big pleasure. So I would reach out to all the winning teams now to sending the prizes. So you saw we have cash prizes, but we also have swag. So all the submissions also get a little mail where they receive some swag, and just make sure that we all have your addresses. But I think we are quite good covered right now. Also, what we would like to do in the next weeks is to reach out to the individual teams to maybe write blog posts or whatever content with your projects, because it's just so much amazing groundwork done. We should talk about it. And as Hamza already said, we are also, as this was a success, we would love to do that early next year somewhere. So this is why, yeah, stick around in our community and listen up what we have to announce. And what also would help is we would like to grow ZenML, the product, the maturity. For that, we also need venture capital somewhere next year. So it would also help us from your side if you can like, comment, share all our articles, LinkedIn, Twitter, whatever. That's just super cool for an early startup to yeah, stick in the heads in the MLOps world. Special thank you as well to our today's judges who are here. Thank you, Charles. Thank you, Goku. It was really, really amazing. And I love to see you around, guys. Everyone, thank you so much. Have a nice weekend. All the best.
Thanks, everyone.
Thank you, everyone. It
Cheers.
was really
Thanks.
good.
Thanks a lot. Take care, everyone.
Bye.
Thank you, everyone.
Bye-bye.
Thanks, everyone.